Okay, good morning everyone. So myself Devabroto Kumar Das from Dumka Engineering College. Today we will take the subject is process instrumentation and control.
Okay, good morning. Am I audible? Please response me, Kajal. Am I audible? Response me, anyone? Am I audible or not?
Yes, sir.
Okay. So very good morning. So we started today class. Today we will discuss the another new module. Okay. That's why we have discussed in the previous classes in our module 3. We have completed. So in this module 4, in this module 4, we have discussed different measurement procedure. Okay, so this measurement procedure, that means in our process control industries, when you have to working in any environment in any industry. Okay, so in that case you have to measure different physical parameter. That means flow measurement, pressure measurement, temperature measurement, level measurement, displace measurement, speed measurement, etc. Okay, so this is the module 4. This module 4, it is very important for your entire syllabus. So in this module we have to explain different measurement procedure of flow measurement, level measurement, temperature measurement, pressure measurement, and also this is the speed measurement, displacement measurement. Okay, so these are the basically different physical parameter we have to measure in our process control industries. Okay, so in your syllabus, uh, only flow measurement, level measurement, temperature measurement, and also pressure measurement. So in details in our syllabus, This is the flow measurement, level measurement, temperature measurement, and pressure measurement. It is also available. And also in this case, another direct measurement. This is the speed measurement, displace measurement, okay, humidity measurement, viscosity measurement, etc. So these are the another topics available, and we have also shortly discussed in our next module or next classes also. So first of all, we have to start the flow measurement. Okay, flow measurement. So what is flow measurement? Any idea, anyone? What is flow measurement? Please tell me, anyone, what is the flow measurement? So this is a basically flow measurement. That means when you have to flowing particular a liquid from one place to another place using the different valve. We have to discuss in our module 3. This is the control valve. Okay. So using this control valve, you have to control the flow measurement system. That means inlet flow parameter, outlet flow parameter. These are the different pressure we have to measure in this flow measurement method. So this flow measurement, it is a basically measurement of flow rate, and quantity is the oldest of the measurement of the process variable in the field of instrumentation. So this measurement of flow rate and quantity is the oldest of all measurement of process variables in the field of instrumentation. Okay, so this is the basically short idea of the flow measurement. So this flow measurement, it is a measurement of flow rate and quantity is the oldest of all measurement of process variables in the field of instrumentation. So it is made for determining the proportion and amount of materials flowing in or out of a process. So this flow measurement is made for determining the proportion and the amount of material flowing in or out of a process. Okay, so this is the basically particular applications of this flow measurement method. So it is made for determining the proportion and amount of material which is flowing either input, that is the input terminal, or output in the output terminal of a process or plant. So this is the basically definition of the flow measurement method. Okay, is it clear? And in this flow measurement method, we have to flow, that is sometime it is also steam flow, sometime it is also available that is a gaseous form, that is a gas flow, and also liquid, that is a water or another liquid, it is also flow in this flow parameters also. Okay, so this is the basically form. Either it is a steam purpose, that is steam flow measurement using this flow measurement method. Sometimes it is also gas variables and also water or any other liquid form of liquid. We have to measure this flow measurement methods also. So this flow measurement method, it is made both of the fluid and sometimes also it is also solids. But in this form, we have to discuss here also basically uses in the liquid form of any others form of liquids and also water as well as also water. Okay. So next is what is the method? Is it clear all of you? Please respond everyone. Is it clear what is the flow measurement method? Why it is required? Okay, this is the basic idea of the flow measurement method. Is it clear? So please respond everyone. There present is 9 participants, but anyone is no response. So this is very bad. Ajay Kumar Hasda. Please respond.
Yes, sir.
Is it clear?
Yes, sir. Yes, sir.
So please everyone respond. Okay, next. Next is method of flow measurement. Methods of flow measurement. So, in many accurate and also any reliable method are available in this measurement of flow measurement also. Some of which is applicable, it is only also liquid and also sometimes it is also present in the vapors and also gaseous forms. Okay, so in this regarding, so many accurate or reliable methods are available in this flow measurement method. Sometimes it is also applicable, some are liquid forms, some of the gaseous form, and also some are the vapors of applications also. So when we have to uh, measure this flow measurement method, sometimes it is also the humidities area or corrosive material, or sometimes it is also wet type or dry type of materials. So there are lots of different procedure we have to uses in the process control industries. So in this regarding, we have to classify basically flow measurement into 3 categories. Number one is inferential type flow meter. Number two, quantity flow meters. Number three is mass flow meters. Mass flow meter. So according to this flow parameters, that means these different forms of measuring flow. That means liquid form, gaseous form, or sometimes also vapors form. So in this regarding, and also the area of the measured variable. Sometimes it is also clean or dirty. Sometimes it is also wet and dry place, humidity area, or corrosive material. So depending on these type of parameters, we have classified this flow measurement into 3 categories. First one is inferential type flow meters. Number two is quantity flow meters and also mass flow meters. So first we have to discuss the inferential type flow meters. Number one, inferential type flow meters. First, we have to know what is the inferential type flow. So this inferential type flow meter is a method. The flow rate is infrared form in the characteristic effect of a related phenomenon also. So this is the basically examples of any measurement that is the inferential type of flow measurement. It is a human body running fever. That is when you have to temperature, your body temperature, it is also sometimes it is also increased. That means the one flu is coming in your body or fever is coming. So that means the running fever. So this is the basically one conditions of the parameter inferential type flow meters also. Then you have to also another temperature of the measurement in hot body, okay, or cold body temperature you have to measure. So this is the basically classification of examples of the inferential type of flow meters. So in this regarding, we have to broadly classify it in this inferential type flow parameters. There are different types. Number one, that is a variable head or differential meter. Okay. Number two, variable area meters. Area meters. Number three, that is a C, magnetic meters. Number D, turbine meters. Number five, E, target meters. Number A, thermal flow meters. Thermal flow meters. Another one I'm written here. Number G, it is the vortex meter. Number H is the ultrasonic flow meter. So these are the basic classifications of the inferential type flow meters. So in this inferential type flow meters, first we have to measure this the flow rate of the inferential methods. Okay, so when a body temperature you have to measurement or any hot body or cold body temperature measurement. Okay, so these are the basically processed in this category of the inferential type flow meter. So according to the application oriented or characteristics oriented, we have to classify these inferential type flow meters. These are the different category. Number one, variable head or differential meters. We have also broadly discussed in one by one. So these are the basically variable head. So in the application oriented, we have to use this different head or pattern. So sometimes it is also difference between the different architecture format. Okay, differential head or differential variable head type of meters. Then also variable area meters according to the application of the area. Okay, that means humidity area. Sometimes it is also cold area. Sometimes it is also dirty area. So this is the basically dependent on the area calculations or area environment. We have to use different variable area flow meters also. Magnetic flow meters. This is the magnetic comparison of also used in the flow meter side magnetic meters. Turbine meters, which is uses in our turbine type of turbulation flow of the different huge amount of fluid where the liquid is flow turbulent speed. Then also target meters. Then another also thermal flow meter. Thermal flow meter is the shortest example, that is a human body temperature measurement. We have to use the human body temperature measurement using the thermometer. Okay, and also you have to certain limited of temperature measurement of the hot body. Okay, so you have to measure using this thermometer also. And another also parameter it is also present, that is the thermocouple measurement. Okay, this is the another temperature measurement also device. Then this is the vortex meter, and also another one is the ultrasonic flow meter. So these are the basically categories in the classification inferential type of flow meters also. So first we have to go the variable head type of differential meter. So this is clear all of you. This is the classification of the different inferential type of flow meters. Is it clear? So now we have to discuss variable head or differential flow meter. Okay, so in this variable head or differential flow meters, there are basically it is uses in the oldest method. Okay, and also it is uses in our most widely used in our different industrial field. Okay, so this is the variable head or differential flow meters. It is the oldest and most widely used methods of industrial flow measurement. Okay, so it measures volume rather than mass flow rates. But mass rates can be calculated or computed easily by knowing or sensing temperature and as well as also pressure. temperatures and pressure. So this is the basically introduction of the variable head or differential flow meters. It is the oldest and most widely used methods of industrial flow measurement also. Okay, so this is measured volume rather than the mass of the different flow rates. Okay, but mass rates, it can be calculated or computed. It is easily knowing or sensing any different temperatures or different pressures also. So sometimes this variable head or differential flow meter, it is simultaneously we have to uses for the flow measurement as well as also temperature measurement and also pressure measurement. Okay, so I am drawing a one example for the variable head and differential flow meter. We just follow the diagram. This is the one input terminal and this is the another terminal. This is the center point where we have to connected one lead. This is another lead. And also here, the one YouTube manometer we have to attach in the inlet and as well as also the outlet terminal. And it is filled by the mercury also. Okay, and this is the filled by the mercury. So this is the basically called the YouTube manometer, where we have to uses in our variable head or differential flow meter type. So this is the field by the different process parameter. So now this is a liquid we have to flow here. This is a liquid. Okay. So this is a liquid we have to flow from here. And this is the one lead we have to connect it in this terminal and another also in this terminal. So according to this lead, so the fluid is flow from here and the bending this process, then it is the flow into the output terminal. So this process is continuing according to this parameter. Okay. This is the so this is the flow. Any liquid we have to flow here. Here one pressure it is measurement here P1 and another is the output terminal P2. Something like that. This is the input terminal IP and this is the output of the terminal of the this liquid. This is the pipe where we have to flow the different liquid. This is the mercury. This is the U-tube manometer. Okay, and this height, that means this height, and U-tube manometer, this height, this is the basically H, and this is the input terminal. It is connected to the input terminal, and this is the output terminal where the liquid is processed. The liquid is going through this terminal also. So according to this YouTube manometer, we have to measure the height from this section and as well as also these sections also. Okay, so this is the basically this is the one terminal we have to attach. This is a orifice plate, and this is called restriction element, and which is used the parameter orifice plate. Using this orifice plate, okay, using this orifice plate, you have to control or flow measurement. You have to measure from here. So when the input pressure that is coming from here in this channel, so the liquidity is also flow in that case. So when the pressure it is going down, one measurement we have to measure from here. Then the outlet temperature, which is controlled by the orifice plate, then we have to as well as also examine from the scale from here. That is the pressure 1 and P1 and P2 we have to differentiate here. So according to the format, we have to use this the application in the different flow meters also. Okay, so this variable head flow meters, we have to operate on the principle of the restrictions of the pipe of the different fluid also. So it is introduced by the orifice plate or venturi tube. Sometimes we have to use as the venturi tube. So this orifice plate or venturi tube or elbow type meters, these are the different parameters we have to use this in the variable head. So we have to tell the different head. This other head is the one is orifice plate, another one is venturi tube, another one is the elbow type of meters. So these are the different flow meters or variable head type flow meters. Okay, so in this case, these are the basically velocity head. It is defined as the uh, vertical distance. It is through the which a liquid would fall to attain a given velocity. So here, one pressure head, it is also changes in the vertical distance. So using this liquid pressure, we have to measure open and in tube. It is the result of the given, that is a static pressure. Okay. So what is the basic equation? The equation is, we have to represent here, this is V equals to K into root over of 2GH by root. Okay, this is the equation 1. Number Q, that is the Ka root over of 2GH by rho. Equation 2. And I am coming in the details of the what is the K, what is the Q, what is the V. Okay, W equals to, that is Ka root over of 2GH by rho. This is the equation 3, where V is the velocity of flowing fluid. V is the velocity of the flowing fluid. Q is the volume flow rate. Okay. W is the mass flow rate. A is the cross-sectional area. Cross-sectional area of pipe, where we have to use the pipe also. So these are the A is the cross-sectional area of the pipe. H is the differential head across the restriction element. Restriction element. Then G. What is the G? G is the acceleration due to gravity. Acceleration due to gravity. Another, that is rho. Rho is the density of the flowing liquid. Density of the flowing liquid. That means you have to uses the different liquid, different flow parameters. Sometimes it is also uses water, sometimes it is also another acidic material. Okay, so the density it is also changes different liquids also. We have to represent that is a rho. So in this case, we have to measure. This is the K. K is the basically a constant. Constant. And what is the K is the equals to C by root over of 1 minus beta to the power 4. So please remember these things also, where I am written here, where C is the discharge coefficient, beta is the diameter ratio, okay. So you have to explain in detail. So these are the basically equations we have to explain. We have to calculate from the differential head or differential flow parameters, where we have to measure first one, that is the V equals to K into root over of 2 GH by rho. Then Q is the what is the V? V is the basically velocity of the flowing fluid. That means in the previous diagram, when the liquid is flow from this section to this section, so one flow rate is also measured. So using this V, V is the velocity of the flowing liquid we have to measure. Then Q equals to, that is Ka root over of GH by rho, where Q is the volume of the flow rate. What amount of liquid it is flowing from the pipe. So this is the basically volume flow rate. Okay. Then this is the W. What is the W? It is the mass flow rate. Okay. This is the another one, mass flow rate. And these are the listen, that is the K is the basically a constant, where K is the C by root over of 1 minus beta to the power 4, where C is the discharge coefficient and beta is the diameter ratio of the flow meter. And A is the cross-sectional area. Okay, cross-sectional area of the pipe. What type of pipe you have to use? This particular we have to mention or maintain a cross-sectional areas. Okay, so these are the basically A. Then H is the differential head we have to use this in the restriction element. So previous diagram, here we have to use this orifice type of plate. So this is the basically orifice plate. Another one we have to tell that is a venturi tube or elbow type of meters we have to use. So this H is the differential head across the restriction element. G is the acceleration due to the gravity. Okay. So everyone please write your own name and roll number in the chat box also. And Saurabh Suman, please respond me. Are you hear me, Saurabh?
Yes.
You take a screenshot, participant list, okay? And after ending my class, you have to send me my WhatsApp.
Okay, sir.
Okay. And everyone write your own name and roll number in the chat box also. Okay, so we have another class also today. So please everyone join after 2 minutes, this ending classes. So G is the acceleration due to the gravity and rho is the density of the flowing liquid. So what type of liquid we have to flow from the flow parameter? So there are different densities are available in the different flow parameters. So these are the basically equations. We have to calculate velocity of the flowing fluid. Q is the volume flow rate and W is the mass flow rate. Okay, it is clear all of you? Next class we have to discuss that is the Reynolds number and also a different flow differential flow meters also. Is it okay all of you?
Yes, sir.
Okay, thanks everyone. So everyone please join after 2 minutes.